Hello, welcome to another simple innovations video. So this video is about an update on the PCB that I've been designing, the circuit I've been designing for monitoring of utilities. And yes, so welcome, walk along with me. Let's see what the progress is. Let's see what changes you have made and where this board can be used. Karibu sana, tusonge mbele pamoja. So before we dive into what the new board looks like, I wanted to have a look at where we have come from. And so that was in 2014ish or 2013. We were building these boards by ourselves, by hand. As you can see, we have a microcontroller down here. This is just the Atmega 2560. On this side you have connectors. We have a connector here for an LCD or some other IOs. Here we had a connector for the SIM 800L. Yes. For all kinds of automation, SMS, GPRS, etc. This was just a quick prototype for testing out something. And as you can see, it was abandoned, never to be followed up. Next, we had this device. This board was actually fabricated, as you can see. We went all the way to fabrication in China, but we never got to do anything with it, so it was also abandoned. Then we designed this board. This was another board. It had a SIM 900, a microcontroller on this side, a SIM card, there's a relay. Similar concepts, boards with some communication, some control of IOs, and some sensors. Then came 2019. We decided to do a simple utilities control system. So we started off with this board. We had a microcontroller here, the 2560 as usual. Seems to be our microcontroller of choice. And the SIM 908 was just lying around. This module comes with GSM and GPS. It has since been discontinued, no longer in production. It has been replaced by more advanced devices. So we had this lying around, and it was great for testing out our idea and just exciting us about what we were about to start doing. So this module worked very well, and it led us to the next stage, which is what we have here. So this one is the first board we designed and assembled. What we have here, testing out, we found that we had done quite a bit of blunders with the design. Maybe because I've not been doing this full time the last few years. I've been doing other things, and of course the board worked very well, but of course with a few errors here and there, which I corrected and also replaced some of the things. The most significant things is that the board became smaller by almost half, and then we kicked out the big LCD, the one you can see all over this place. We removed the RTC, which was using this battery, and the SD card. And what we did is that we decided that whoever needs those provisions of hardware, then they can implement it on their own on the new board. So I'm going now to go ahead and show the new board and what it is like. So we designed a new board, and here it is. This is the newest board, very small in size, as you can see. We have removed the power switch mode power supply module. We have now integrated it on the board. We have also provided an area here where the user can prototype his or her own things. We provided debugging USB for the SIM 868 so that you can upgrade the firmware and do other things with the device, even if you wanted to do embedded AT. The microcontroller remains the same, the Atmega 2560. Very robust, used with the Arduino Mega, so you can just program like an Arduino. We have maintained the communication. This is RS485, and yeah, so this board came out a little much better than the previous one. We removed the LCD and just put a connector here so that whoever is using the board can just connect the LCD and position it wherever they want with a ribbon cable. And yeah, so we also moved the SIM card to this side, as well as the opto isolators. They are on this side, so they are not on the upper side as they were in the previous board. So yeah, so that's the progress. And of course the device is also here, fully assembled and working. Let's see what it is. Yeah, so here we have the device. It's currently reading a power meter. The power meter we have on the left, and publishing that data to our cloud system. So as you can see, we have made the output relay drivers. They are now surface mount as compared to the previous ones, which were through hole, and that the device is now much more compact, and the use of space is much more efficient. So we are actually intending to use an off-the-shelf box for it, so that it can be mounted on a DIN rail, and then see how this works. So we've been tinkering with the power meters. This is one of them that we have, that we are currently reading. I'll try and see if we can do just go through what it is doing. You can see there we have 0.3 kilowatts. That's what my computer is consuming right now, because only that is plugged in. But as you can see, we are almost ready. Actually, I was very impressed because the mistakes we corrected on the previous one, all of them turned out well. Only that I still have a small bug somewhere within the hardware, so another one revision is required to be done. So as you can see, we have some very the board is almost mature now, almost ready for production. And yeah, so I'm going to go into the dashboard and see the kind of data we are getting from the meter. And yes, load, we use an iron box. This iron box will be simulating our load, and we'll be seeing how much power it's drawing from the mains. Yes, we are currently connected. So here we have the real-time monitoring, or using the GSM based data logging system. Here we have an iron box as the load, and looking at the data coming in from the device, we see that there are these big peaks around 1280 watts as from the iron box right now. Right now the element is off, and so we have these 297, like just some small loads within that are connected to the system. And when the iron box comes on, you'll see the power shoot to a very high amount, like 1000 watts. So basically that's what we have just done right now. Of course, the board has much more capabilities to connect. As you can see, that's a single peak. So as I was saying, the board has a lot of capabilities to connect other sensors. You could connect analog sensors, 4 to 20 milliamps sensors. You could connect digital sensors like level switches for tanks. You could connect various other sensors, and all that data can be represented on a dashboard like we are seeing right now. So the board has matured, but of course for now we have to settle with what we have, because a lot is happening with the current situation with the coronavirus. We are not able to order new boards as quickly as we would wish to do, and as such it's we have to contend with that until the situation has calmed down a little bit. So we are looking forward to make another version of this board, but that would be the very final of this set of boards, and that would now contain all the changes that we have made, and that it will serve the purpose we intended it to serve very well. Yes. Thank you very much for watching my video. I'm hoping to bring you more and more projects that we'll be doing with this board. Please subscribe if you haven't, so that you never miss any of those upcoming interesting videos. Thank you very much.